Hi, my name is Lena, and I will be talking about 7.1, number 34. So we have our equation f of x equals square root of x minus 2, where a equals 2. Part A, it tells us to prove that this function is one-to-one, and to do that, you have to prove that the graph is always increasing. So if you draw out the graph, you can tell that it'll always increase and never go down. Part B, we have to find the derivative of inverse of a, where a equals 2. And you can rewrite this equation as 1 over the derivative of f of inverse of 2. From this equation, we know that the inverse at 2 has to equal value x. So f of x equals 2. So we set the function x minus 2 equals 2, and we get x equals 6, meaning the inverse at 2 equals 6. So I would plug this into our equation in the beginning. Our next step is to find the derivative at 6. So we have our original function, and set the derivative at 6 by plugging it in. And you get the answer 1/4. So 1 divided by 1/4 would equal 4. And once again, 4 would equal the derivative of the inverse at 2. Part C, we have to find the inverse of x, and to do that we need our original equation and switch the x and the y's to get the inverse equation. And we solve for the new y. So our inverse equation is y equals x squared plus 2. And our next part is to find the domain and range. To do that, we can look at the graph. The range, which is the x value, starts from 2 and goes to infinity. And the y values goes from 0 to infinity. Part D, we have to prove that our calculation in Part B matches our answer in Part C. Part B states that the derivative of the inverse at 2 equals 4. And we have the inverse equation x squared plus 2, and to find the derivative we get 2x, and since a is at 2, the derivative at 2 equals 4, which matches our original answer in Part B. Part E, we want to graph the equations on the same graph. So we have our original at the point 2, 0, and our inverse graph we find by just switching the x and the y coordinates at 0, 2.